Okay, hello everyone. My name is Yumi Tomita. I work for Cybertrust Japan as security marketer.
I'm Atsuya Misaki. I work on Cybertrust in Japan. In Japan.
We are both work for Cybertrust Japan, and Cybertrust Japan is one of the company as Open SSF. And today we have other speaker, but he couldn't be here, so I will play his video. And today we have a presentation, future use of SCAP and SBOM for software supply chain security. And supply chain security is becoming more important in Japan. It is important to have a system to objectively ensure security throughout the supply chain. Regarding organization systems, products, services, data, etc., with respect to trading partners and other stakeholders. One of the conventional tools used to evaluate vulnerability is SCAP or OpenSCAP. And SBOM has become a hot topic in recent years to ensure transparency throughout the software supply chain. SBOM is expected to be used for vulnerability checking and compliance management. But today we're going to talk what are the differences compared to SCAP and SBOM, and why SCAP no longer in use compared to SBOM. Okay, here is today's agenda. First, introducing the use of SBOM in Japan. I play the video. Then we'll show you what is SBOM and what is SCAP briefly, and what difference between SCAP and SBOM. Finally, we'll discuss in the future use of SBOM and SCAP. Then, firstly, Masaki Ishiguro shows the Japanese government efforts.
Think tank in Japan. Going into the agenda, it is my great honor to talk on the Japanese government efforts in software security and SBOM. I am Masaki Ishiguro of Mitsubishi Research Institute. Before going into the agenda, I would like to briefly introduce myself. I have been involved in many cybersecurity initiatives funded by the Japanese government, such as NISC, METI, MIC, and also been involved in committee members in cybersecurity. Today, I would like to talk on the Japanese government efforts from the viewpoint of a private think tank in Japan. So this is the agenda of my talk. First, I'm going to outline the whole picture and the structure of Japanese government agencies and initiatives on software security and SBOM. Then I'll describe some initiatives by the ministries which I have been involved in. So this is the structure and overview of Japanese government initiatives on software security and SBOM. The Government Cybersecurity Strategic Headquarters takes the role of the highest control tower of the Japanese cybersecurity policy and legal system. And its secretariat agency, NISC, is in charge of overarching and coordinating cybersecurity programs conducted by all the ministries in Japan. They publish common standards for cybersecurity measures for all the government agencies and related agencies. Two major ministries that are leading cybersecurity programs in Japan are Ministry of Economy, Trade and Industry, that is METI, and Ministry of Internal Affairs and Communications, that is MIC. METI operates task force for examining software management methods for ensuring cyber physical security and published guidance on SBOM and software security. MIC has been funding research and POC on SBOM in telecom sector and will publish SBOM guidance this fiscal year. The major guidance on SBOM in Japan is METI's SBOM guidance, and it is referenced by many companies in many industries. Its English edition is also referenced by the CISA's document titled Shifting the Balance of Cybersecurity, which is internationally signed by many national government agencies. This guide is also referenced by MIC's POC on SBOM. The important point of SBOM guidance by the METI is that it provides an SBOM quality model that quantifies the coverage of components, software components, and the coverage of vulnerability detection. This enables procurer to understand the level of quality of SBOM before they purchase the software and its SBOM along the supply chain. The MIC launched POC and trend survey to compile guidance for telecom industry on SBOM. The industry consortium, including telecom carrier, network appliance vendors, incorporate SBOM quality model in their POC, and Mitsubishi Research Institute has been taking charge of compiling SBOM guidance for telecom industry and will be published the guidance in the end of this fiscal year.
Now let me explain SCAP and SBOM. SBOM is the scale content automation protocol which was created to standardize the formats and naming of software vulnerabilities and security policies through a set of certification to reduce the burden of vulnerability and patch checking through automation and to promote the operation of security products. SBOM is the software of billable materials, which is a list of software to be created, a list of external libraries and software to be used with the software, and meta information such as license and creator, and SBOM was created to ensure the transparency of software. Both have in common that they can be used to manage security compliance. Recently, it is said that SCAP may replace SBOM, but how can it be replaced? SCAP is managed by NIST for specification and consists of these 5 elements: language, reporting format, and identification scheme, assessment, and scoring system integrity. Using information for security checking is written in language such as XCCDF and OVAL provided by operation system vendor and software vendors. And information about vulnerabilities SCAP tools are used to scan and output scan result based on ARF. This SCAP tool is also provided by open source project, and the most famous tool is OpenSCAP. SCAP can be used to evaluate the vulnerability inherent in a system and to evaluate security policies such as PCI DSS, HIPAA, and NIST SP 800 families. For example, in the evaluation of security policies by specifying XCDF that describe a security policy checklist on the target chassis, and executing the OpenSCAP tools, you can obtain the result for the explain nears or not a weak password has witnessed. SCAP is used in Red Hat Satellite. Red Hat Satellite is a security compliance management tool, and Oval and XCD are also provided by Armaniacs, in which we at Cybertrust have joined since last year. Here's an example from the Armaniac speak, which includes our guide to security compliance management using SCAP. SBOM is composed of 3 elements, which the NTR publishes the minimum elements of SBOM. SBOM can also be used to access vulnerability based on the package information described in the SBOM. It is also expected to be used for license compliance management. There are various SBOM scanning tools such as Toribi, Shift, SBOM tools by open source project. Then both SCAP and SBOM can be used for vulnerability assessments. So how are the two different? So the use of SCAP has the advantage of preventing depending on the operation because it is referred to standards and uniform vulnerability information. SCAP has not just system information, but has how to check system status. On the other hand, SCAP has a disadvantage that the scope of vulnerability testing is limited. Due to the difficulty of expressing this vulnerability in the dependency relationship and the number of vendors that provide such information is shrinking. For example, OpenSCAP has not been supported for Windows officially since a few years ago. Using SBOM has the advantage that SBOM tools are well developed now and can clearly vulnerability in dependency. On the other hand, there are some disadvantages. Detection rates may differ among scanning tools, and information on package identifiers may prevent matching vulnerability information. Other difference from SBOM is that SCAP can assist security compliance. SCAP can assist security according to policy management by the SCAP security guide. The tool also allows you to select rules and create your own policies. So you can add supply chain security rules, for example, supplier relative risk in the future. This is very important aspect of the system operation. Also, it is outside the scope of the SBOM.
Finally, the future of SCAP and SBOM. SBOM was used for vulnerability and security compliance assessment, but now SCAP is being replaced by SBOM for vulnerability assessment. SCAP has no alternative as a security policy inspection to assess the state of the system, and its specifications are sufficiently standardized that users can trust it. But as for why SCAP has not become popular as the main security compliance assessment tool, for software providers such as software vendors, it is because because of the complexity of the description language and the cost of creating OVAL and XCCDF. Also, from the users' point of view, SCAP did not become popular because the number of vendors supporting SCAP tools is shrinking. Thus, SCAP and SBOM each have their own characteristics. For example, by managing supply chain security vulnerabilities with SBOM and inspecting the status of the system operated with SCAP, users can operate system with supply chain security assured. However, it is not possible to say that the SBOM provides a perfect vulnerability check. For example, sometimes there is no complete identifier to identify the package. The provider of the SBOM needs to have sufficient data fields, which makes the provision of the SBOM costly. Also, the SBOM has incomplete package identifiers. The customers, the users, needs to double check that the vulnerability assessment is correct due to the lack of sufficient data fields. These are stressful costs for both providers and suppliers and users. And I would say this is what happened with SCAP as well, and it is a problem in the spread use of the security tools. As Masaki Ishiguro mentioned earlier, there is some guideline or some regulation in Japan, but most of companies are still looking for stable system operating to ensure software supply chain security with SBOM. This problem is not only for supplier, but also public organizations, vendors, suppliers to need to support the cost of providing data that can be used as the basis for evaluations such as OVAL or SBOM. And users need support for tools that are easy for users to operate. And support for the community is needed to improve support for the tools. The collaboration is often mentioned as a challenge at LF events these days. But I would say the real collaboration challenge in Japan is the cost for supplier and users. For example, one example is to do this would be to provide financial support from the government for the cost of providing SBOM to users, or to users for like important open source projects that are used on many services like that. I think I don't know this problem is if it's unique to Japan. So or there are some people today. There are some people from governments today. So I would be happy to hear your opinion or your future plan. That's all for our presentation. Thank you for your time today.